There is a storm on Jupiter that has been raging for longer than modern science has existed, a spinning vortex of gas and violence so enormous that Earth would fit inside it, and no one, not a single scientist alive today, can say with certainty why it is still there. It has survived for more than 350 years. It has outlasted empires, revolutions, and the entire history of modern science. And right now, at this very moment, it is still turning. This is the Great Red Spot, and it is one of the most terrifying things in the solar system. From a distance, Jupiter looks almost peaceful, a massive sphere of ochre and cream, wrapped in elegant bands of color that drift in slow, hypnotic arcs. Through a backyard telescope, it is one of the most beautiful sights the night sky offers. You can see the cloud belts clearly. You can see the 4 great moons orbiting in perfect rhythm, and if you look closely at the southern hemisphere, you will see it, a reddish oval, sitting quietly among the clouds like a bruise on the planet's face. For a long time, early astronomers were not sure what it was. Some believed it was a solid feature on the planet's surface, perhaps a mountain or a plateau of some kind rising above the cloud tops. Others thought it was simply a peculiar atmospheric discoloration, something like a patch of different colored gas that would eventually drift apart and fade. It looked, from that distance, like something almost ordinary. It is anything but ordinary. The Great Red Spot is a storm. Not a storm in any sense we experience on Earth. Not a hurricane, not a typhoon, not anything that fits inside human vocabulary without being reshaped. It is an anticyclonic superstorm. A high-pressure system so massive, so self-sustaining, so brutally powerful that it has been spinning continuously for at least 3.5 centuries. The first confirmed telescopic observations of the storm date to the 1660s. It was already enormous then. It had almost certainly been raging long before anyone noticed. At its peak, the Great Red Spot was wide enough to swallow 3 planets the size of Earth placed side by side. Even today, in a period of measurable shrinkage, it remains larger than our entire world. The winds at its outer edge reach approximately 450 kilometers per hour, nearly double the wind speed of the most powerful hurricanes ever recorded on Earth. And unlike a terrestrial hurricane, which burns out when it loses access to warm ocean water, the Great Red Spot has no ocean to lose. It feeds on Jupiter itself. Imagine approaching it, not from the safety of orbit, but descending, falling through Jupiter's upper atmosphere toward the storm below. The first thing you would notice is the scale. Even from hundreds of kilometers above the cloud tops, the storm fills your entire field of vision. It is not a feature on the planet. It is the planet in that moment. The outer bands of the vortex move with a speed that seems almost calm until you realize each cloud formation you are watching is the size of a continent moving at hurricane force. Closer in, the turbulence becomes catastrophic. The boundary between the Great Red Spot and the surrounding jet streams is one of the most chaotic regions in the solar system. A zone where competing wind systems collide, where smaller storm cells are torn apart and consumed, where lightning discharges thousands of times more powerful than anything on Earth erupt without warning from the cloud layers below. The storm does not just spin, it devours. Inside the vortex itself, the clouds tower upward for dozens of kilometers, driven by convective forces that dwarf anything in Earth's atmosphere. The colors shift, Deep reds, burnt oranges, streaks of pale yellow, the result of complex chemical reactions between phosphine, sulfur compounds, and organic molecules being churned up from deep within the planet. The chemistry is still not fully understood. The exact compounds responsible for the red coloration remain, after all this time, a matter of scientific debate. But something even stranger lies beneath. To understand why the Great Red Spot exists, you have to understand what Jupiter actually is. Jupiter is not a planet in the way Earth is a planet. It is a world made almost entirely of gas and liquid, with no solid surface, no ground to stand on, no boundary where the atmosphere ends and something firm begins. It is, in essence, a storm all the way down. Jupiter rotates faster than any other planet in the solar system, a full rotation in just under 10 hours. For a planet of its size, that speed is staggering. That rapid rotation drives powerful jet streams in the upper atmosphere, east-west wind bands that circle the planet continuously and never stop. These jet streams define the banded structure you see from space, and where jet streams of opposing directions meet, instability forms. Vortices spin up, storms are born. On Earth, storms die because the energy sources that feed them are finite. On Jupiter, the energy source is the planet itself. Jupiter radiates more heat than it receives from the Sun, driven by slow gravitational compression deep in its interior. That internal heat rises constantly through the atmosphere, fueling convection, feeding the jet streams, sustaining the conditions in which a storm like the Great Red Spot can survive indefinitely. On Cosmic Vision, we explore worlds that challenge everything we think we know about the universe. And Jupiter challenges more than most, because the Great Red Spot is not alone. Jupiter's atmosphere contains hundreds of storm systems at any given time, oval storm cells that have persisted for decades, white ovals that occasionally merge, combining their energy into larger, more powerful systems. In 1998 and 2000, 3 such white ovals collided and merged into a single storm that astronomers named Oval BA, a system that subsequently turned red, echoing the chemistry of the Great Red Spot itself. Jupiter does not just produce storms, it manufactures them. And the lightning on Jupiter is unlike anything in the inner solar system. Bolts have been detected that release energy thousands of times greater than the most powerful lightning strikes on Earth. These discharges occur deep within the water cloud layers, far below the ammonia clouds, visible from space, in a region of crushing pressure and total darkness. They flash in their millions across the planet's surface, a perpetual planet-wide electrical storm operating beneath everything you can see. So why, after all this time, do scientists still not fully understand the Great Red Spot? The honest answer is that Jupiter is almost impossibly difficult to study. Its radiation belts are ferocious enough to damage spacecraft. Its atmosphere has no accessible surface. The probe NASA dropped into Jupiter's clouds in 1995, released from the Galileo spacecraft, survived for just 57 minutes before the pressure and heat destroyed it. In that time, it returned extraordinary data. But 57 minutes against the full depth of a Jovian atmosphere that extends thousands of kilometers is barely a scratch. What we do know is that the storm is changing. In the 1800s, the Great Red Spot was estimated to be nearly 50,000 kilometers wide. By the mid-20th century, it had shrunk to around 25,000 kilometers. Today, it measures closer to 13,000, still larger than Earth, but roughly a quarter of its former size. The shape has changed too, shifting from an elongated oval toward something closer to a circle. Some scientists believe the shrinkage will continue. Others believe the storm may stabilize at a smaller scale and persist for centuries more. A few have raised the possibility that the Great Red Spot could eventually. The Juno spacecraft, currently in orbit around Jupiter, has been studying the storm in detail, unavailable to any previous mission. Its instruments have probed the storm's vertical structure, revealing that the Great Red Spot extends hundreds of kilometers deeper into Jupiter's atmosphere than anyone previously suspected. It is not merely a surface phenomenon. It is a deep, three-dimensional engine with roots that descend far into the planet's interior. What that means for the storm's future is still being calculated. The data is still being processed. The answers have not yet arrived. And perhaps that is the most unsettling thing of all. We have been watching this storm for more than 3 centuries. We have sent spacecraft to orbit the planet, to fall through its clouds, to study its magnetic field and its moons, and the chemistry of its atmosphere. And the Great Red Spot still holds secrets we have not unlocked. It spins in the dark, hundreds of millions of kilometers from Earth, indifferent to our instruments and our questions. A storm older than modern astronomy itself, embedded in a planet that generates its own heat. Sustained by forces that operate on timescales the human mind struggles to contain. Jupiter is not a backdrop. It is not a distant curiosity. It is a reminder, cold and enormous and utterly indifferent, that the universe operates at scales and speeds and durations that make human history look like a single breath. The Great Red Spot has been there since before your country existed, before your language existed, before almost everything you know existed. And tonight, if you step outside and look up, it is still turning.